Hello academic stars, welcome to Caltex Academy. Today on our board I have this question posted by one of the students from grade 9 that says, why is the volume of cone V equals to 1/3 pi r square h? I have set two goals for this video. One of the goals is to help learners who want to explore ahead of their teacher and know something before they learn in class. And the second goal is also to help teachers to refresh their knowledge before teaching in the next lesson. So with all this, I'm going to walk you through slowly, leaving no stone untouched. And with all this said, let's get our hands dirty. So when we take a look at the question here, we can make a sketch of a cone. What is our first step? Go ahead and get the equation of this line. And how do you get the equation of this line? Remember, at this point we have h and r. So h is along x axis and r is along y axis. So at this point, this is the center O with coordinate of 0 and 0. And we know how to get equation of a straight line. So equation of straight line is always presented by a general formula, that is y equals to mx plus c, where m is the gradient and c is the y-intercept. So let's get the gradient of this line with point O, and this point we can call it P with coordinates of h, r. So m is the same as change along y coordinate and change along x coordinate. We can make a substitution. The y value is r minus the y at this point is 0, and we divide this by x at this point is h, and x also at this point is 0. So when you subtract 0 from something, you are left with that something. Therefore, our gradient is r over h. Now, since c is the y-intercept, and you can see by visualizing that y at this point is 0. So you can simply ignore this c. Therefore, the equation becomes y equals the value for m, that is r over h. And then we attach our x, and we know c equals to 0, so we leave it there. Now, if you are curious, you can also use the other approach of getting equation of a line, and that equation of a line can be gotten by y minus y1 equals m into x minus x1, where x1 is h and y1 is r. So let's make a substitution for us to see how this c got removed from here. So we have y minus y1 is r equals our m is r over h. So you place it here and you multiply by x minus x1 is h. So we can open up this bracket and we have our y minus r equals r over h, and x attached to minus also r over h times h. So this h will cancel here, and we will go ahead and take this r to the right hand side. Therefore, we have r over h x minus, we're left with r here, and as this negative r crosses equal sign, it becomes positive, and we have here r. Now you can see clearly that this negative and positive r will cancel, and that is why the value of this y is the same as r over hx. Exactly like what we've gotten before here when we assumed that our point O is at 0, 0, therefore C-intercept is 0. So in case you do not want this reasoning, then you can go ahead formally using our formula to get the equation of the line between O and P. So that is one of the main steps. And the second step we need to do is to redraw this diagram here, and we need to also have some estimation of an area, small strip, and this strip will be here. So this strip is in form of a rectangle. Now our rectangle here is with a small distance delta x, and from here up to there was r. So we can have this in terms of maybe y, because this value r is along y-axis, and because this one is vertical, then this must be also y-axis. Now what happens if we rotate this? And that is exactly what I was saying earlier on, that we need to have a certain drawing for us to be able to illustrate this concept. As we rotate this along x-axis, remember this is our x-axis and our rotation is going to be in this direction, then we'll form exact area down here. So let's go ahead and do that, and we can go on and have several strips drawn here. So let's have the radius here, and this radius will be, since we have given here y, we can call this one here to be y1, and that is the distance from the center of this small disc. We're going to use this method, of course, of finding out. Then I also want to have another disc drawn here. We're also going to have this y2 as the radius of this disc. Remember, the disc has different radii. Now this is the same as delta x, assuming the thickness of the disc are the same. So we have here delta x, and the distance from 0 up to this point is h as the height of this cone. Now what do we do next? So let's move on and approximate this area. Now assuming we have taken one of these discs and pull it out, now this small distance here is the same as the height delta x, and from here as the center to here is the value y. So this is representing the general one here. Otherwise, if you have drawn several of them, the value for y increases from 1, 2 up to infinity. So how do you get the volume here? And since it is a small disc, then we need to have this approximation. And in our approximation, what we can do, we will have the volume of each one of this disc as delta V, as the volume is given by the summation. So we have the summation of r, and r is the radius of each one of these from I ranging from 0 up to infinity here. So we can say I is the same as 0, 1, 2, and so on. Therefore, volume of our small disc we have drawn here, this one is the same as this area. Maybe I can have some heading. The area of the top here, or the base, multiplies by the height, and our height is delta x. We know it is a circular disc, so it is characterized by pi r square h. So from our drawing up here, h is delta x and r is the same as y. So we have delta v equals the summation as r ranges from I to infinity of pi, and we have y square delta x. So what we have done here is the volume of we selected this. For us to be able to get the volume of the whole cone here, we can go on and approximate it using integration to get the accurate volume of this cone. So we have here delta v will be dv. Now we have to integrate this. So this sigma notation also will be replaced by integral sign, and we're integrating from the value for I is 0, because as you can see from here, we're starting from 0 up to this h. So we're integrating from 0 up to h, and we have pi y square, and we turn also this delta x to dx. In our step number 1, we had the value of y as r over hx. So let's make a substitution to our formula. Now from here, the integral of 1 with respect to v would yield us v as the volume. The left hand side is already coming up. Now we'll still rewrite our integral sign from 0 up to h of pi, but this time since pi is constant, we can pull it out, and we have y replaced by r over hx, and since y is squared, we can also move on and square this quantity inside here with respect to x. Therefore, we have to square all these terms, and rewriting pi and integral from 0 up to h, squaring r, we get r square, squaring x, we also get x square, and squaring h, we have h square with respect to x. Since the integration is with respect to x, then r square and h square is a constant. We can pull it out to join this constant here, and we have v equals to pi r square over h square, integral from 0 up to h of x square with respect to x. So from here, it is easy to integrate. V equals, copying our constant, we have pi r square over h square. Then we can create a bracket since we have limits, and integrating x square, we raise the power by 1. So from 2 to 3, and we divide by our new power 3. Then we close up this bracket, and our limits are running from 0 to h. These are the limit. The lower limit comes here, and the upper limit there. So let's move on, and we have v equals pi r square over h square, and this is multiplied by inputting h cube over 3. Remember, we said this is minus 0, so just ignore the 0. And now you can see here that these 2h will cancel with one of these, and some people normally get confused at this stage. What you can do here, remember h cube is the same as, if I rewrite it here as h over h square, this is the same as h times h over the 2 of them here, h times h. So 2 of this will cancel, and we're left with only 1, and that is the step we have here. And we have v is given by pi r square, and this h which is left, 3 is a denominator. Now we can bring it down, and with this, that becomes the formula of cone, and it answers our question as the origin of this formula you have been using without knowing how it is derived. If this video helped you, please support this channel also by subscribing and share this video with a friend so that your friend also learn from. And see you in the next video, where we're going to discuss about volume of a sphere, how we can also derive the volume of a sphere. Peace out.